Biotechnology, and on my personal behalf, I welcome you all to the 39th Foundation Day of Department of Biotechnology. And I also wish you an auspicious and a blessed Mahashivratri. May I now invite Secretary, Department of Biotechnology, Dr. Rajesh S. Gokhale, Dr. Sameer V. Kawan, Secretary, Department of Defense, R&D, and Chairman, Defense Research and Development Organization, Professor C.R. Babu, Distinguished Professor, University of Delhi, to the dais, please. May I also request Dr. Alka Sharma, Scientist S and Senior Advisor DBT, Dr. Sanjay Mishra, Scientist H and Senior Advisor DBT, to join them on the dais, please. We begin this program with invocation and lighting of lamp. For lighting of lamp, I request Secretary DBT Dr. Rajesh S. Gokhale and Dr. Sameer V. Kaman, Secretary Department of Defense R&D and Chairman DRDO, along with Professor C.R. Babu, Distinguished Professor, University of Delhi, to join and kindly light the lamp. May I now request Secretary, Department of Biotechnology, Dr. Rajesh S. Gokhale, to formally welcome our Foundation Day speaker, Professor C.R. Babu, Distinguished Professor, University of Delhi, with a potted plant and a shawl. I would now request Dr. Alka Sharma, Scientist H and Senior Advisor DBT, to formally welcome Dr. Sameer V. Kawan, Secretary, Department of Defense R&D and Chairman DRDO, with a potted plant and a shawl. I request Dr. Sanjay Mishra, Scientist H and Senior Advisor DBT, to formally welcome Secretary DBT Dr. Rajesh S. Gokhale with a potted plant and a shawl. May I now request Dr. Garima Gupta, Scientist F DBT, to formally welcome Dr. Alka Sharma, Scientist H and Senior Advisor DBT. I again request Dr. Garima Gupta, Scientist F DBT, to formally welcome Dr. Sanjay Mishra, Senior Advisor and Scientist H DBT. Thank you, ma'am. I now call upon Senior Advisor Dr. Sanjay Mishra to kindly deliver the welcome address.
Chairman DRDO, Professor C.R. Babu, Distinguished Professor, Delhi University, and Dr. Alka Sharma, Senior Advisor, DBT, former scientists, my colleagues, officers of the Department of Biotechnology, staff, and the fellow colleagues and students who have joined from NII to celebrate the Department of Biotechnology Foundation Day. I welcome each one of you who have joined this celebration today. I would like to welcome all of you for the 39th Foundation Day of the department, especially to Professor C.R. Babuji, who has given this time to deliver the Foundation Day lecture on a very, very contemporary and important topic for all of us, for the DBT family. I believe the restoration, especially the ecological restoration, has got a new dimension and is much more important in the present context than it was in the past. So his cherished academic and professional career will be a beacon for all of us and lessons to be learned. So I'm looking forward for that foundation lecture, sir. And also I welcome you that you have given time. And I just to recall that he has asked me that to give 45 minutes. So just to let you know that sir is so passionate about his, about his work, not only for teaching and research, but also his real life work. So I look forward for that. Thank you, sir. And thank you. I think I do not have words to express my gratitude to the DRDO head who has given his time to bless the Department of Biotechnology, all the staff and scientists on today's, by giving his time on a holiday. So thank you, sir. And I welcome, especially for you, for joining us on this 39th Foundation of the Day. Now, as far as the Foundation Day is concerned, it comes every year. So I just thought that why this Foundation Day, it comes and what is its meaning for all of us. So in my opinion, there are two purposes. Again, it's my opinion, the Foundation Day. One, it reminds us the rationale, the objective for which the department was created 39 years ago, which I believe that very often we start work in directorates and divisions and in various positions, but we often forget the overall objective of the department or the organization to exist. So this gives us a very, very important occasion where all of us need to think, rethink, recall, correct ourselves to work in a team so that we can be on the track to achieve those objectives. And this is very important. I believe that not only in DBT, but I believe in the most of Government of India, we are more common. We are working in our own department division and forget the bigger picture of the objective. So that's one point. I think I'll not tell the details, but I think this is just a reminder to all of us. And I believe that I take a pledge, and all of us should take on today's pledge that we all will work together for the objectives of the department. That's the first thing. And the second point is, I think there are very less occasions when whole department as a whole works together for a common cause or a common meeting. Foundation Day is one of them where I believe that it reminds me and all of us to work as a family, irrespective of the position and division and everything, to work together. And third thing, when we work together as a family, then it also asks to celebrate our successes in last 1 year which has happened. So this is all from the Foundation Day purpose, I believe, to remind. And again, once again, I think welcome each one of you, the Secretary DBT and DRDO Chief, my colleague Dr. Alka Sharma, and Professor C.R. Babu, who have given time for this very, very special moment of the department. And once again, to all my colleagues in audience who have come on a holiday, on a religious holiday, and those who have come today, I again extend my warm welcome on the Foundation Day. So thank you very much.
Thank you, sir. For the Foundation Day lecture, we are joined by an expert in environmental conservation, a field that has gained renewed attention and increased significance amidst the numerous climate change events being witnessed globally. Professor Cherukuri Raghavendra Babu is a renowned Indian botanist, ecologist, and environmental enthusiast, known for his significant contributions to biodiversity conservation and ecological restoration. Currently, he's a Professor Emeritus at the Center for Environment Management of Degraded Ecosystems. His work focuses on taxonomy, ecology, genetics, and sustainable biodiversity use, with over 200 scientific publications to his credit. One of Professor Babu's notable achievements is the conceptualization and development of biodiversity parks in Delhi. In 2001, Professor Babu was tasked with transforming a 156-acre barren area along the Yamuna River into a thriving ecosystem. He embarked on this ambitious scheme along with his team to restore the area's ecological balance, and his efforts led to the formation of Yamuna Biodiversity Park, now home to diverse flora and fauna, including previously lost species. Under his leadership, Delhi now boasts of 7 such biodiversity parks, which help mitigate pollution, recharge groundwater, and provide habitats for numerous species. Professor Babu's research advances ecological restoration. He has also been a strong advocate for environmental conservation, influencing policies and strategies on land degradation and biodiversity preservation. His work has earned numerous accolades, including the Indira Gandhi Paryavaran Puraskar 2009, the Vaspik Award 2005, and the Narayan Dutt Award 2008, recognizing his dedication to environmental conservation. I can go on about his many achievements. So without further delay, let's seize this opportunity and listen to Professor C.R. Babu as he shares his insight on ecological restoration of the degraded ecosystems.
Please use this call. This one. Put on my slide.
Respected Dr. Rajesh Gokhale, Secretary to the Government of India, Department of Biotechnology, Ministry of Science and Technology, other distinguished VIPs on the dais and off the dais, distinguished staff of DBT, faculty of NII, and other invitees. Let me thank the Secretary for inviting me to give this lecture on the occasion of 39th Foundation Day of Department of Biotechnology. It's a great pleasure for me, an honor for me to talk to you today on ecological restoration of degraded ecosystems, a key approach to human survival, on the occasion of the celebration of 39th birthday of Department of Biotechnology. Before I start my presentation, I would take 1 minute or 2 minutes to say something about Department of Biotechnology. I've been associated with the Department of Biotechnology for a period of 3 decades in one way or other. The department is not new to me. I've seen the progress of the department in different areas. I say the Department of Biotechnology has witnessed a phenomenal growth in terms of scientific achievements, infrastructure development, and capacity building in emerging areas of biotechnology and molecular genetic medicine. This is possible because as one of the what you call distinguished organization in the world map of biotechnology. And I wish the department will attain new height in the coming years. With this brief remarks on the Department of Biotechnology relating to its 39th birthday, I would now come to my presentation on a topic which is slightly away from the mainstream of biotechnology, not completely isolated from the biotechnology, but mainstream of biotechnology. Now, before I go into the ecological restoration, I must tell you very briefly about the ecosystem, about the what you call the degradation of ecosystems, and also the way by which we can bring back these degraded ecosystems to the natural state, and also to illustrate success stories of ecological restoration. This is in brief what I'm going to talk to you today in the next 40 to 45 minutes. What's an ecosystem? You may ask me why I am telling about the ecosystem. If you cannot recall what you have studied earlier, what I will say in the rest of my lecture, you will not be able to appreciate it. That's the reason why in 1 minute or 2 minutes, I will tell you what's an ecosystem. Any area ranging in size from few millimeter squares to several thousand kilometers square, where the 4 environmental components interact with soil, that is soil and rock, water, air, and water interact within and among them and form a complex, dynamic, self-sustaining, functional, natural system called ecosystem. What happens in the ecosystem? What happens in the ecosystem? In any ecosystem, interactions among these 4 environmental components result in a wide range of ecological process. The products or the outcomes of these ecological process are what are known as ecosystem services or ecological services. perhaps most of you might not have followed what I told. For example, biochemical weathering of rock fragments is an ecological process resulting from interaction among these four components, and its products are outputs or outcomes are soil formation and release of minerals. Both these are what you call ecosystem services, in the absence of which life cannot exist on this planet. You can see how important the ecosystems are. Now, the ecosystems generate a wide range of ecosystem services, all of which are broadly classified into four categories. The provisioning services, that is, which include the food we take, the water we drink, the clothes that we wear, the shelter where we live in, the fuel that we use for cooking, and the drugs that we use for maintaining health, all derived from the ecosystems. These are the provisioning services. The life-supporting services include nutrient cycling, primary productivity. All these constitute life-supporting services. The regulatory services include climate change, flood regulation, disease control, etc. And cultural services, which include aesthetics, recreational, spiritual, and educational values. All these contributed to human well-being. You may ask me, what do you mean by human well-being? Security, basic material for good life and health, and good social relations constitute human well-being. Now the question is, what is happening to these ecosystems? Anthropogenetically mediated land degradation, industrialization, and urbanization have been threatening the natural ecosystems. In fact, some of the ecosystems were extinct or lost, and others were highly degraded. And still others are in the process of degradation. Take, for example, land degradation is a major 21st environmental challenge. 75% of global lands are degraded. And this figure will touch 95% by 2025. In India, 32.07% of the total geographical area is degraded. This means 105.8 million hectares of land is degraded, of which 81.4 million hectares already desertified. That means nothing can grow there. According to some reports, 60% of the total geographical area is regarded as a wasteland. Somewhere between 50 to 700 million people migrate if we do not halt the present level of degradation by 2050. 87% of the world's wetlands were extinct. The well-being of 3.2 billion people, that is 40% of the global population, is undermined due to land degradation. Land degradation is threatening food security and access to clean water and clean air for most of the world's citizens. The annual land degradation reached the soil and water, leading to further degradation of the ecosystems. I just want to bring to you this slide. What are the consequences of the loss of the or degradation of the ecosystems? What will happen if the ecosystem do not exist? Can human beings exist on this planet? Let me tell you, the loss and degradation of ecosystems are responsible for a large number of minor and major ecological disasters that you read every day in the newspaper, sometime on the front page. I don't want to read this. I have given the list. You can see here. All this is happening. Now let me tell you, this I listed based upon my field experience in different parts of the country during my field service. What is the ultimate fate? The ultimate fate is, I'm sorry, today is a religious day, but I'm telling you that you must remember what's happening. Is extinction of civilizations. Is not new to this planet. It happened in the past. Great civilizations were perished due to paleo-ecological perturbations. And this may happen if we do not take care of bringing back the lost and degraded ecosystems to their natural states. I just one and perhaps the only way to address all the complex environmental issues which I listed is to bring back the dead ecosystems to the natural state. This can be achieved only through ecological restoration, which is based on restoration principles, community. What is ecological restoration? Ecological restoration is a young scientific discipline and is the only hope for the future of the environment. And the planet future depends upon its development. Let me tell you, these are not my statements. These are statements given by internationally known ecologists from different parts of the world. Ecological engineering, what it involves? It involves assemblage of native species into ecological communities that promote biophysical process such as soil development, nutrient cycling, and moisture retention, leading to the redevelopment of ecosystems. The ultimate outcome of the ecological restoration is the establishment of biodiversity park. Establishment of an ecosystem that Now, I just want to tell you, the ecological restoration is entirely different from reforestation, afforestation, and ecological rehabilitation. This, you must remember it. Don't confuse it. And this confusion is responsible what we have today in the country. Reforestation and afforestation create new ecosystems consisting of mostly monoculture plantations and do not provide all the ecosystem services that are needed for the human well-being. Ecological rehabilitation does not allow to reach the natural state of ecosystem, but it gives halfway and provides some ecosystem services. So therefore, what we need is not afforestation, reforestation, ecological rehabilitation, but what we need is ecological restoration. Ecological restoration can take many forms, such as ecological restoration of mined-out areas, ecological restoration, and assembling them into ecological communities, and then introduce these assemblages on the site. This is the first step. The second step is inoculate these plant species with the microbial inoculants for their growth, for their establishment and growth. And third is monitoring of the habitat response for ecosystem redevelopment. And last one is evaluation of ecosystem services of the restored ecosystem. Of degraded ecosystems, University of Delhi has been carrying out ecological restoration of mined-out areas, and there are several success stories to the center's credit in bringing the dead ecosystem to the what you call natural ecosystem within a period of 5 to 10 years. Similarly, the center has been what you call evolved Department of Biotechnology, and a small grant from Steel Authority of India, and using the ecological restoration inputs, the scientists at the center have successfully restored 250-acre barren dolomite mined-out area of Steel Authority of India in Purnapani, which is about 40 kilometers from Rourkela in Orissa, to a 5-story rainforest ecosystem within a period of 10 to 12 years. The rainforest ecosystem has 5 stories, with the top story reaching to height of 100 feet, the second story attained height of 60 feet, and the third story height of 20, and the ground cover is covered by herbaceous plants. These restored are rearing Tassa silkworm, lac insect, and also many forest plants that produce nectar-bearing flowers. The center trained the local self-help groups in rearing Tassa silkworm, lac culture, and practicing apiculture. What the net result is? The net result is there is a substantial increase in the socio-economic status of the local communities. In addition to the mined-out area, the center also restored 200-acre, 40-meter deep mine-wide water reservoir to full biological productivity by introducing phytoplankton and zooplankton. And introduced 1 million fingerlings, and each fingerling has developed into an adult fish weighing about 12 kg. And the local communities have adopted fishing as their livelihood. This is the best example of sustainable development. And some of the investigators associated with the project are in the audience: Dr. Sudeshna Muzumdar Lighton and his student Vivek Chaudhary. They also played and Suman Lakhanpal, Department of Botany. They're in the audience, and I just want to show you the slides now. Now, this is the 250-acre plot of dolomite mined-out area. You can see the mine benches, and behind that is what we call the natural hillock. Originally it was a hillock, but due to mining, the whole area has become flattened and contains nothing left. And beneath that is a mine void, which do not have any productivity at all. Now, we use this site with the help of the grant from DBT and the small grant from, and we successfully restored back. You can see the same site after 12 years. It's a 5-story rainforest ecosystem. Why it is 5-story rainforest system? The rainfall is very heavy in this area in Orissa, and this is. And then it has the same site in a different view, and this is the restored site, and the other side is the natural hillock. And you can see that the vegetation in the restored site is much more denser and rich, and more species rich as compared to the natural hillock, which is located next to it. And you can see the structure of the forest that has been developed, of the ecosystem that has been developed. And then you can see this is the tree which has reached to 100 feet in just 10 years. And it will reach up to 150 in the next 5 years. It's a very fast growing tree. And this is the 60 feet, second type, this goes up to 60 feet, and it forms a 3rd story. And then you have many small trees with a 4th story. And in the 5th story will be represented by small herbs and grasses that grow on the ground. Now, this is the host plant, Terminalia tomentosa, on which the locals rear Tassa silkworm, which produce silk cocoons, and each cocoon fetches 5 rupees. And last year, not last year, about 2 years ago, they got about 5 lakhs from harvesting these cocoons on these host plants. And this is different species of products that are used in medicine. Now, there are wild mushrooms on the forest floor. The local communities harvest these mushrooms and sell in the market. And the bottom slide where they sort out the cocoons and then sell it in the market. And you can see the fish which weighs about 15 kg. Each, we introduced 1 million fingerlings, and to provide food to 1 million fingerlings, we introduced phytoplankton and zooplankton. All right, now I will not go into further. There are many stories, but which I am not going to tell you. Now come to my second example, second success story. Delhi has 2 life-supporting landforms. The last spurs of Aravalli mountain ranges. Both these landforms lost their life-supporting potential. Why? Due to loss of natural heritage. That is, due to loss of natural ecosystems. What is the net result? The net result is that what we are facing every day in Delhi. Air pollution, other excess heat island effects, water scarcity, and highly vulnerable to any climate change leading to extreme events. There is no buffering of the weather in Delhi. Why? Lost its natural heritage, natural ecosystems. Now the question comes is, how to bring back the lost natural heritage in the developmental matrix of Delhi? To bring back the natural heritage in the development matrix of Delhi, we evolved and implemented for the first time an innovative conservation concept, that is biodiversity park concept, jointly in collaboration with Delhi Development Authority. What are biodiversity parks? biodiversity parks are unique landscapes or riverscapes of wilderness where ecological assemblages of native species are recreated in the form of biological communities on 50 to few hundred acres of marginal or degraded landscapes or riverscapes. In other words, biodiversity parks are nature reserves and harbor natural heritage, that is natural ecosystems, and have cultural, educational, and conservation values, promote or enhance the environmental quality of the area, and also contribute to the environmental sustainability. The biodiversity parks simulate national parks, wildlife sanctuaries, or wilderness, but are smaller in size. What these biodiversity parks contain? The biodiversity parks conserve populations, species, communities, and ecosystems which are essential for providing a large number of ecosystem services. These biodiversity parks also render a wide range of ecosystem services worth of several millions of rupees annually. There are 7 biodiversity parks in Delhi, developed and managed by Center in joint collaboration with DDA. These 7 biodiversity parks spread over an area of 3,000 acres across the city and harbor 3,000 species of plants and animals and render a wide range of ecological services, which I am not going to explain to you. It will take more time. Worth of several millions of rupees and contribute to environmental sustainability. Now, these are the 7 this is the map of Delhi. These are the 7 biodiversity parks located. You are free to go to any of these biodiversity parks. What I want to say about these biodiversity parks is, we develop plant communities. We have not introduced any animal. Natural rewilding has taken place in most of these biodiversity parks, which I will explain to you. I'll show you 2 biodiversity parks, not all the 7 biodiversity parks. I'll show you the Yamuna Biodiversity Park. The first biodiversity park developed perhaps in the world is the Yamuna Biodiversity Park. Spreads over an area of 457 acres, located in the upstream of Wazirabad Reservoir, along the bank of the river Yamuna. It has 2 phases. Phase 1, which is located on the inactive floodplain, which never receives flood water, and phase 2, which receives flood water every year. I can show you some of the slides. Now, okay, there is a slide which is missing here. Now, this is the drone picture of the Yamuna Biodiversity Park. You can see the human settlements, you can see the river, and you can see our wetland. And this was a barren area. Now today you have what you call 10 diverse floodplain ecosystems with canopies reaching up to 35 to 40 feet and harboring both what we call a wide range of biodiversity, a rich biodiversity. Now let me tell you. This is the visited area. This visited area, there was nothing except a few salt-loving grasses and bushes, and we restored it back into diverse plant communities. It has a rich wildlife. Let me tell you, today if you go, a leopard is there, living as a part of the ecosystem. And we have a hog-deer. We have a wild boars. We have what you call jackals. We have a wild cats. You name any of the wildlife, the entire wildlife has come back into the system. All right? Now, this is a drone picture showing a restored wetland. And along the restored wetland, you can see how we developed this rich biodiversity, rich ecosystems with a rich biodiversity. And let me tell you, this water in these wetlands is linked to the water in the river Yamuna. In the flood season, the water level increases, and in the dry season, the water from these wetlands feeds the channel. So you can see how these ecosystems are linked together. There is what is known as ecological integrity, and that among these ecosystems. If you break the ecological integrity, you find all kinds of environmental issues, including your pandemics. Pandemics is outcome of the disruption in the ecological integrity of the ecosystems. Now, this is a silted wetland. We desilted and we restored. Within 6 months, we got 5,000 birds, migratory birds on this. This is a restored wetland. It is because of this success, DDA has convinced that these biodiversity parks would play a significant role in the environmental sustainability, and that's the reason why from one biodiversity park, they've declared 7 biodiversity parks covering an area of 3,000 acres. Now, this is my phase 2, which is a tiger habitat. Tiger can come at any time. I may not be here, but tiger will come very soon into this habitat from Rajaji National Park through a river corridor. Now, you can see there's a one wetland, and that wetland, the left side is the, what you call, before starting the biodiversity, before restoration, and after restoration is on the right side. You can see the floodplain forest and the floodplain wetland and floodplain grassland. We have 10 different types of grasslands on the what you call floodplains. Now, that wetland is about 100 acres. It stores 500 million gallons of flood water every year and provide adequate amount of groundwater to the neighboring communities, and also supply water and feed the water to the main channel of the river during the lean season. And this is the overview of our phase 2. You can see, let me tell you, during flood, what happens to all these ecosystems? They are flood resilient. In the last year, the flood water entered, stayed for 35 days, up to 7 meters depth, and after 35 days, the water receded. No change in the ecosystem. The entire ecosystem is intact, indicating these ecosystems which we restore are flood resilient, automatically climate resilient. That means extreme climatic conditions will not change. In other words, these ecosystems try to buffer the extreme events to make it, to moderate, so that the less damage will take place in the.
Please use this mic.
Is all right, sir?
I think there is a problem with that mic. Can you? Oh, thank you. Sorry.
Now I'll just tell you about the Aravalli Biodiversity Park, which is located very close to this institute. Now you can see the natural rewilding has taken place. We have not introduced any animal, not any insect. We have about, to begin with, we have 35 birds, and today we have 300 birds. To begin with, we have 15 butterflies, and today we have 7 butterflies. And there are a large number. You can see the leopard. The leopard exists today. If you come to our office, if you are lucky enough, you can see the leopard. Now this is the Aravalli Biospheric Park, spreads over an area of 692 acres, located very close to Vasant Vihar, Vasant Kunj, Mahipalpur area and JNU. It has all the forest communities of Aravallis extending from what you call Gujarat up to Delhi. It has about what you call 2,000 species living in the form of 50 to 75 biological communities, all native to the Aravallis. Now, this was the scenario. 85% of the landscape is composed of moorland pits and scattered bushes of most aggressive invasive species, that is Prosopis chiliflora, which is a native to Mexico and pumps the water like what you call as if you are extracting the water using the diesel pumps. Right? And such habitat we transformed into, you can see, a luxuriant, dense, mixed broadleaf forest community. And then we have a thorn forest, and then we have a very unusual, extinct ecosystem. This is Trichula urens, Baudolia serrata ecosystem, which was extinct in the Aravallis, but we brought back in the Aravalli Biospheric Park. And I must tell you, these birds were observed about 50 to 100 years ago. All of a sudden disappeared. But now they have come back and made the restored Aravalli Biospheric Park as their home. And these are some of the wild animals that have come on their own in the Aravalli Biospheric Park. Now, if you want to see the beauty of Aravallis in Delhi, you must visit this park. The landscape is composed of a series of shallow valleys separated by low range of hills. It's a beautiful landscape. An entire landscape looks like the African savanna, and you find leopard stays in the night here. Because it's very close to Asola and Bhatti Wildlife Sanctuary, so those animals migrate into this area, and this is a restored Tirupati Valley Biodiversity Park, which spreads over an area of what you call 200 acres, located close to scenic pumps. Now, I just want to tell you, as a sample study, what kind of ecosystem services the trees in some of the biodiversity parks are providing to the Delhiites. We studied economic valuation of 2 lakh trees found in the Aravalli Biodiversity Parks, which are very young. Now you look at this, the 2 lakh trees of Aravalli Biodiversity Park alone stored 10,279.9 tons of carbon, worth of 13.9 crores. And sequester carbon of 1,409 tons per year, which is worth of 2.03 crores. This is wrong. 203 crores, not 2.03 crores. The trees also help in recharging the rainwater to the groundwater to the tune of 60,116.72 cubic feet per year, and is worth of some 3.5 lakhs. And remote pollutants, 11.0 tons per year, and worth of 72.35 lakhs per year. Now let me tell you, realizing the importance of these biodiversity parks, the NGT ordered to establish these biodiversity parks all along the floodplains of the rivers in India, including Ganga, as a part of their rejuvenation. Now the National Mission Clean Ganga has taken up this and entered into an agreement with the Delhi Development Authority for utilizing the knowledge that these biodiversity parks have in establishing these biodiversity parks along the floodplains of the rivers of India. Now, lastly, I'll take another 5 minutes or so. Many countries in the world are facing water scarcity. India is water deficit country, and Delhi is facing acute water scarcity, everyone knows. Yeah. One way to address this water scarcity problem is to recycle and reuse wastewater, including sewage. Now, there are many conventional technologies like STPs, which are widely used for the treatment of wastewater, particularly sewage. But these STPs have some limitations. What are those limitations? Very expensive, high energy consumption, difficult to operate and maintain, and low performance under Indian climatic conditions, and also what you call inefficient in the removal of emergent pollutants, including pathogens. Now, are there any other technologies? There are alternative and complementary bioremediation technologies, which are often called as the nature-based solutions, which are less expensive, inexpensive, not less expensive, inexpensive, does not require energy. Easy, very simple, easy to operate and maintain, high performance under Indian climatic conditions, and efficient in removal of emergent pollutants, including pathogenic organisms in the sewage. Of the different nature-based solutions used for the treatment of wastewater, constructor wetland system has been widely used across the world in the treatment of wastewater. I must tell you that we at the center developed rock filters and plants only for the treatment of sewage in smaller drains, and an integrated constructor wetland for the treatment of sewage in larger drains. When I say smaller drains, the flow is less than 10 mld, and larger drains means flow is more than 10 mld up to 75 mld. Now, how the rock filters and plants work in the treatment of sewage? This is the question that you ask me. That when you have a rock filters having a different pores, when the sewage water flows through it, through these pores, a turbulence is created. And this turbulence will make air volume fraction increases and water volume fraction decreases. As a result, the sewage water gets saturated with air and more dissolved oxygen is present in the water. But once more dissolved oxygen is present, there is a more microbial activity and more efficient removal of pollutants. What do plants do? We use 15 to 20 plants, and these plants harbor billions of microbes in their root zone. We studied the microbiome of these with the help of Professor Sudeshna. We found out that these microbial community have a trophic structure. That means it includes some predators. And these predators will remove all pathogenic organisms from the sewage. And plants will remove heavy metals. As I already told you, the removal efficiency of the pollutants by these nature-based solutions vary from 75% to 99.5%. for different water quality parameters. For some water quality parameters, the efficiency is 99.9%, and for some water quality parameters is only 75%, particularly for heavy metals and phosphates and nitrates. Now, using these technologies, we have successfully treated 1 LD of raw sewage at Nelha's Biodiversity Park and 50 mld of raw sewage and industrial pollutant in Fulda drain. These are two big stories. Nelha's Lake is located in Sanjayvan Hills in a small depression and used to hold fresh water from all the surrounding hills and used to supply drinking water South Delhi. But due to urbanization, the freshwater supply was disrupted, and the only source of water for the lake is a sewer carrying untreated sewage of 1 mld. With the result, the lake is dead. The residents filed a case against PWD government that this lake is to supply drinking water, and we must, the government, the agencies which have destroyed, must bring back to its pristine glory. Then the court has asked the government to restore it back, and since the land belongs to DDA asked us to develop a biodiversity park, and our job is first to deseal the lake, and we did it, and we used this silted material as an embankment and developed a rich biodiversity all along the embankment to regulate the water temperature, which in turn determine the quality of water. And then how to treat this sewage. We developed an integrated constructed wetland consisting of 2 stabilization units and 1 gravitation channel and 1 filtration unit and a constructed wetland. And this constructed wetland treats this 1 mld in less than 12 hours and make it a clean water, and that clean water is used for restoring the lake. Now let me tell you, this water quality has similar to that of water used for bathing. And I have 2 videos of, one is of maybe 1 minute and the second maybe 2 or 3 minutes. I'll just show you. Can you see this? This is not moving. It's a video. It's not moving. This is the... All right. You can see this is the drain carrying a raw sewage at Nelha's, and is passing through the drain, and then it is entering into our stabilization unit, and then entering into gravitation channel, then entering into filtration zone. You can see the rock filters, and then is the constructed wetland having plants and ridges with rocks, and you can see the water. You can see the quality of the water. This is all in less than 12 hours, sir. And no electricity. You can see the entire lake is restored. You can see the quality of water. We have not used any enzymes, sir. We have not used any microbes. And now this is the restored lake. You can walk to the Nelha's and you can examine yourself how this lake has been restored and how our constructed wetland system is functioning. So there is a second case, Fulda drain, which is a tributary to Saina Escape Canal, which in turn discharges content into Ganga. Near Simboli in the Upper district. And the Simboli has a sugar mill and a distillery unit. And they used to send the sugar mill effluents and distillery effluents into Pulara drain. And this used to go into Ganga, make Ganga water red color. There was a case, the NGT, asked the distillery unit to pay 5 crores to the CPCB for restoration of this Pulara drain. And CPCB asked us to see whether this bioremediation technology, the constructed wetland system using rock filters and plants can work. We said, yes, we'll try. Now we did it, and I must tell you, the result is successful. We have a, can I have that? That. And the water is clean, and you can see yourself. We use just rock filters, sir, and plants, nothing else. You see this? This is the Pulara drain. You can see our rock filters passing through it. You see the plants, and you, sir, this is rock filter. One rock filter, water is passing through it, and then there are aquatic plants which harbor fairly large amount of microbes in the root zone. You can see the quality. Sir, it is about nearly 1 kilometer stretch. We have used this. We have used about 15 to 20 rock filters. You can see this is the rock filter, sir, through which the water is passing through it. And then you have the plants, about 15 to 20 plants. There is one plant species which can change pH from 14 to 7, sir, in 72 hours. This is Alternanthera pungens, is a floating plant. And it changes the color of the water in no time. You can see the water's qualities. Very recently, this technology we have used at Gorakhpur on the request of the Chief Minister of UP, and we restored 5 drains, small drains, and 1 major drain which pollute river Rapti, where they have constructed a big bathing ghat, and we successfully treated the sewage into clean water. Now clean water goes into that. Recently, the Chief Minister visited and appreciated and directed all the commissioners of UP to use this technology for remediation of the small drains and other polluted rivulets. Today, this technology of using rock filters has been widely accepted by many people across the country, sir, because there's an urgency. Otherwise, our rivers are polluted, and we do not know what we are drinking and what we are eating. In some of the rivers, the polluted water is used for irrigating our vegetables. If you go to East Kali, the entire polluted water containing industrial effluents and pesticides residues are used for irrigating this. You can see, sir, the water. This is about 1 kilometer stretch, the constructed wetland. So I thought I should show you this to indicate how these simple technologies can bring out solution to our serious ecological problems. And you can see the fish in the water. So this entire work has been done by a team of committed scientists, and some of them are in this audience, and some are there in the biodiversity park. This is not I just simply a team leader for this group. Otherwise, the work has been done by the committed scientists. Without them, it is not possible to achieve this. If you have any questions or some clarifications, I would be very glad to answer. But I also want to request you, sir, still a lot of science requires here. Scientific inputs have to be, if you can bring into these solutions, it will be a wonderful, which I am trying to see how best to make it more scientific so that repeatability and can be easily practiced by a common man. That I am just looking at.
Hello. Professor Babu, namaskar. Sir, can you hear me?
Yes, yes.
Yeah, I know you, when you were Pro-Vice Chancellor of the University.
There is a more story,
So I have seen you just in one pant and shirts for years and years, and you were managing your life very simple way, and you have such a high-skilled work, and technologically we need such kind of. So I am interested. No, I notice a considerable amount of algae in your this remediation technology. Are they also contributing something?
Technology.
Algae in remediation water. So algae also protect.
I think.
Algae.
Plant.
Kai.
Algae. We have not been wrong here, sir. Now let me tell you, sir. Algae will not work in the running system. They run away. They go away along with the water. Right? There's a need for interaction between the algae and the pollutants in the sewage water. And along with the flowing sewage water, the algae also move. But somebody has developed diatoms which they put it at the sediment level, and then they say they generate oxygen because of photosynthesis, and that oxygen would do it, and it has failed at many places in the standing water. So these are, I also want to tell you, all of you, we don't require additional space. All these technologies are implemented in the drain itself, in the running drain itself. The in situ remediation. And if you ask additional space, land is not available, simply not available. So therefore, these are all in situ remediation technologies. I have been looking at these algal technologies, and I was a member of the environmental development. It's very nice, but one works on a large scale because, and also dosing. Dosing is a very, very expensive job. Say enzyme technologies, there are a number of enzyme technologies. And bee technologies. This dosing is very expensive, and these won't work in the running system. Whereas in the pond, polluted ponds, remediation, it may work.
Second question. Fantastic work, very inspiring. About 200 years before, in Jodhpur area, the king wanted it to be green. It was not green, so they took help of some Britishers and then planted Prosopis juliflora.
Yes, sir.
And they tried to make it green. It became green, but in a long run, it so happened that the bird never came, it never given fruit, and the soil also did not get porous enough to collect water. My question is, we did something thinking good, and in about 200 years we realized that that was not the right direction of making it green. So what kind of generalized solution would you give if somebody want to restore a dry land?
A patch.
So that is the patch, yeah. So what kind of general solution?
Sir, you must survey the native ecosystem, which is undisturbed in the neighboring areas, as a reference. Sir, ecological restoration is always with reference to undisturbed, relatively undisturbed ecosystem. Find out the species, mostly the desert bushes and desert trees. There are, if you want, I can give you the list of the trees. I know it, what species they grow in Jodhpur area. and those species you can utilize it and develop into a nice natural ecosystem which attract the wildlife as well as the birds.
Thank you.
Thank you, Dr. Babu. It was a beautiful experiment and restoration work done, which I have been observing in the last 15-20 years around Delhi. I was not sure who is behind all this work. It is really good. Another part is other than the restoration, you talked about the cleaning of the waterways.
Yes, sir.
Waterways are polluted because we have some source of them from where the polluted start. And that source is either the residential complexes, homes, or the industries. Can we think in terms of putting small such treatment units for the homes and industries which can easily clean the water right at the source? You must have heard the quotation, nipping in the bud.
Sir, this is the proposal which the National Mission of Ganga wants to implement it along the Ganga river because they could not succeed in getting our river Ganga, free from pollutants. The reason is the residents, the villages are located along the bank are directly sending that raw sewage into the Ganga. Right in Varanasi, sir. Right away, I have two urgency calls from the commissioner, Varanasi city, because the chief minister told immediately you rectify the remediate the sewage which is discharging into Ganga and Varuna and Nasi from the residential areas.
Actually, why I asked this question,
You are right, sir. This is the best way to address the problem of water pollution.
why I asked this question was because around 30 years back I studied the leather industry around Chennai,
Yes.
and government has given them time to put up the water treatment plants, but unfortunately they could not put, and maybe around 1,500 industries were closed that time there.
But now the National Mission Ganga has realized, sir, and they are going to implement this.
Thank you very much.
Thank you very much, sir. Thank you very much.
I hope I am not I just told what I
Thank you, sir, for a thought-provoking talk that aptly linked human well-being with environmental preservation. I would invite Secretary DBT Dr. Rajesh S. Gokhale to felicitate Professor C.R. Babu by presenting a memento, please.
I have already
Thank you, sir. May I now invite Dr. Dr. Garima Gupta, Scientist F, DBT, to brief the audience about the Sahaj portal.
Thank you, Sumita. Respected Professor Babu, Honorable Secretary DRDO, Secretary DBT, revered senior advisors on the dais, and all the dignitaries of the dais and colleagues. It's my privilege to brief you about the Sahaj portal. Can we have the slide? Well, it's not required. So, Sahaj scientific infrastructure access for harnessing academia, university, research joint collaboration, a portal that the department embarked upon several years ago. From a humble initial effort that led to the portrayal of all the resources under Sahaj web page, to the present-day dynamic portal that is soon to be launched, I would say that it had not been possible except for the dynamic leadership of our secretary, Dr. Gokhale. This project would not have even taken off. DBT decided in 2018 to consolidate its resources created so painstakingly across the country for benefit of the entire nation. It was agreed that equipment more than 50 lakhs should be consolidated under Sahaj so that researchers could access these, and of course with some user charges which would be available at a gradation. Like for academic users, it would be little less, while from industry, it would be more. Since its consolidation, we could track the users of various facilities listed and their revenue generation. The development of Sahaj portal was initiated in 2024 as a joint work between DBT and BRIC ILS Bhubaneswar. With the consolidation of BRIC institutes, the Sahaj Unified Portal assumed a new dimension where it would provide seamless services to all of the 16 DBT BRIC institutes. In the phase 1, we have made available the resources of DBT BRIC institutes, while in the second phase, we shall onboard the remaining research institutes and universities where DBT has supported major research infrastructure. I would now invite Dr. Debashish Das to showcase the creation, as this has been possible only due to his untiring efforts. The team Sahaj, as we call it, comprises of Dr. Debashish Das, Dr. D. Pradhan, Sushant Das, Ipsita Acharya, Manisha Rath, Pratyush Sinha, and Renukesh Verma. The continuous monitoring by Dr. Sagar Sen Gupta, Director BRIC and IBMG, Dr. Debashish Mohanty, Director BRIC and II, Dr. Ashwini Parikh, Executive Director BRIC Navi Mohali, Dr. Chandrabhas, Director BRIC RGCB, has culminated in today's event. So, Dr. Das, please.
Can someone please help me to put up the slides first? Thank you, Garima. I think this has been long planned. Lot of thoughts have gone in. The entire idea was to share our resources, which are so very costly, and then to have a proper utilization. So with the team of IT people, scientists, and like-minded people, we thought, why not we create something like Book My Show, where a platform where you go and then see what all resources are available. In next 2 to 3 minutes, in fewer slides, I would like to share with you what all it has. So thank you. So as you can see, this is a equipment booking portal. 16 institutes are currently a part of it, all the iBrick Plus institutes, as well as we have more than 40 type of equipments are there, categorized as genomics, proteomics, NGS, metabolomics, animal facility, all this. And more than 400 services are also available through this portal. Yeah? Not audible?
It is audible.
Yes. So this is in a snapshot of what all it has. Being a data scientist, I love to showcase how, across the institute, what kind of facilities are heavily represented and what kind of facilities are only unique to some of the institute. This will also tell us where we need to invest more to have geographical presence of such kind of facility. Of course, it will also lead to how much of usage across institute we are going to have. This is only a presence of such services, such instruments are available. Very simple logic. In about a minute, I would like to share that anyone can search what are facility available anywhere, but they have to have a login, pre-register and login to book an instrument. Once the equipment is booked, there are the 4 key players. One is the service requiring institute's nodal officer, and the other person is service providing institute's nodal officer. Between the two, if the agreement is there that, okay, the instrument is free and you can use it, then the booking process is complete. Once the booking process is complete, the equipment in charge books the slot and confirms the booking. So all these things can be monitored centrally by the admins through a dashboard and report generation. How many users are there? What is the equipment usage? Who are mostly service providing and who are service taking, so on and so forth. Initially, we thought of, instead of giving money to each other within the IB Plus Institute, why not we give tokens? And the token is a representation of money, but not exactly money. So that is the thought process. Sorry. As Dr. Garima told, the team is right here who have given a lot of input. And next is inauguration, then the video. Okay. That browser. Yes.
I now solicit Secretary DBT Dr. Rajesh S. Gokhale to formally launch the unified online portal for utilization of resources or facilitate created under DPT Sahaj. May I also request
Click on the launch. Please join us. A lot of time. Don't tell me again. Oh, thank you. The screen was idle so long that the page got expired. So there is a small movie which I like to play here, which tells us about this.
India's recent shift towards igniting innovations through various startups is limited by non-access to cutting-edge scientific equipment and experiments. This slows progress, stifles innovation, and prevents us from reaching our full potential. Introducing Sahaj, a national platform aligned with the BioDBT policy, democratizing access to cutting-edge scientific instruments and unlocking India's research potential. It empowers scientists with world-class resources to drive innovation. Our vision of Vasudhaiva Kutumbakam in this endeavor has resulted in the Sahaj portal, which embodies this by fostering collaboration and inclusivity in research, ensuring that all researchers have the tools they need to contribute to global innovation. Sahaj facilitates seamless access to state-of-the-art research equipment for researchers, scholars, and innovative startups across India. This serves as a complete ecosystem for scientific excellence, featuring an intuitive dashboard with real-time insights and quantitative analysis for data-driven decision-making. Sahaj spans the nation, connecting researchers, high-end equipment, and experiments of 16 leading institutions of the Department of Biotechnology. Sahaj empowers you to save valuable time, accelerate your research, optimize resources, share resources, and reduce costs. Foster collaboration, connect with researchers nationwide, receive expert support, get guidance from experienced technicians. Join the Sahaj revolution and contribute to a Vikshit Bharat. Sahaj, where innovation knows no boundaries.
No, it should come from. Okay. Okay, so thank you all, and please use it. Give us constructive feedback if it gives any glitch. Homegrown tool, and more we use, I think we'll be able to make it more popular. Thank you.
As you are aware that Biotechnology Research Innovation Council has been formed for unified governance of all the DBT AIs. During the celebration of first Foundation Day of BRIC, a unique competition was organized. Developing industry-ready products and launching new ventures can often seem like an overwhelming challenge, especially in the field of biosciences. As a small push towards this direction, Race from Science to Entrepreneurship competition was organized during the first Foundation Day of BRIC to encourage young doctoral students to develop entrepreneurial skills, encourage students to think creatively, and explore issues involved in commercialization of biosciences. During this competition, 28 teams from across iBrick Plus participated, and the top 5 teams were awarded as winners, and they were awarded a cash award of rupees 8,000. Several teams presented well-rounded ideas with clear business plan, and jury recognized the efforts put in by students. One of the eminent jury members, Dr. Anand Deshpande, founder and chairman, Persistent Systems, appreciated the ideas and generously announced a cash prize of 1 lakh to each winning team with a suggestion to work on their business plan and make it more comprehensive at par with a new venture. The sponsored funds were given to BIRAC, which will be distributed to the 5 winning teams today on the occasion of 39th Foundation Day of Department of Biotechnology. May I request Dr. Samir Kamant, Chairman DRDO, to kindly present these awards, and I also request all the dignitaries to join in award distribution. First of all, I invite the NIPGR team for receiving the certificate as well as memento and award. I also request the mentor for the NIPGR team, Dr. Senjyoti Sinha Roy, to join. May I also request MD BIRAC to kindly join on the stage. Oh, he's already here. May I also request Dr. Kalavani Ganeshan, all the iBreak directors, Dr. Richi V. Mahajan, to kindly join on the stage. So Ms. Priya Upadhyay from Team NIPGR, they presented the winning idea, vegan meat that bleeds like real meat. For the next award, I invite Team ICGB, Dr. Robin Kumar. I'm sorry, I request Director NIPGR to kindly join on the stage to receive the cash prize on behalf of NIPGR.
Director as well as mentors are the team members.
Next, I call upon Team ICGEB, Dr. Robin Kumar, Dr. Babal Rihar, Mr. Saeed Ghulam Razi, and Ms. Vinisha Garg, who presented the winning idea, biomanufacturing of a flavoring agent, tetramethylpyrazine, having beneficial pharmacological properties. I also invite the team mentor, Dr. Syed Shams Yazdani, and Director ICGB to kindly join this. Next, I call upon Next, we have Team Brick Nabi Mohali, Dr. Nitesh Priyadarshini and Ms. Priyanka Garg, who presented the winning idea, BactoSense, a smart approach for on-site detection of bacteria in contaminated sample, having beneficial pharmacological properties. I also invite the team mentor, Dr. Nitin Kumar Singhal, Dr. Parekh is joined online with us. He's not present in person here. May I request Dr. Parekh to kindly switch on his video camera?
Anand responded to switch on the video. Please join Anand online.
इनके ऑर्डर ये है कोऑर्डिनेट वालों के.
I'm also happy to announce Dr. Anand Deshpande has also joined online. May I also request him to kindly switch on his camera? Thank you, sir. Next, I call upon Team Brick Thisti, Dr. Jayanti Kumari, Ms. Devhuti Palan, Dr. Chaitali Singhal, Ms. Sweta Pandey, and the mentors Dr. Shusmita Chaudhary, Dr. Neeraj Kumar, Dr. Shinjini Bhatnagar, and Dr. G. Karthikeyan. They presented the idea Onco Alert Rapid and Point of Cure Screening Test for early detection of oral cancer. So next team is also from Brick Thisti. Ms. Devhuti Palan, Mr. Akash Patel, Dr. Jayanti Kumari, Mr. Kumar Nishchay, and mentors include Dr. Neeraj Kumar, Dr. Sushmita Chaudhary, Dr. Shinjani Bhatnagar, and Dr. G. Karthikeyan.
Yes, please. Wait, Momo.
They presented the winning idea, concept note for Clever Cup, an automated midstream urine collection device.
Yes, please.
Anyone can take, anyone, I think you can take all of this.
Yes, ma'am.
Team leader and mentor.
Yes, please, follow me. Wait a minute, Momo. Please. Thank you.
Commendation letters. Thank you, sir. So, next we have distribution of commendation letters. But before that, I would invite Dr. Sanjay Mishra, Senior Advisor, to kindly brief the audience about the Mission Karam Yogi.
I think for self-learning at your own pace, at your own time, that was the best part of this whole new initiative. And this particular program, what we have done today, we have identified the 5 topmost staff, employees, scientists who has studied, who have learned, who have been using these and brick family. And today we would like to congratulate them and to say them well done. And I expect the same thing in the next year. More people will be benefited. And there's a commendation letter which has been given by the Secretary, Department of Biotechnology.
Mr. Fong Lian Pao. I hope I pronounced it correctly.
Yes, please. Thank you.
Next we have Mr. Sonu Gupta from NII New Delhi. He has completed 95 courses. So the next is Mr. Moolchand. He is from DBT headquarters and he has completed 85 courses. However, he has not been able to join due to some personal commitments. Yeah, that's it. Thank you, sir. Okay. May I request Dr. Anand Deshpande, who's joined online with us, to kindly say a few words. Over to you, sir, please.
Hello. Unfortunately, I'm not very well situated right now. I'm at an airport in Dubai. But I wanted to congratulate the team members for their phenomenal work. Last time when I was there for the first anniversary of BRIC, it was very clear that some of the people had done
On the presentation. Yeah.
Thank you very much for coming here today. I think you had absolutely stunning lecture and of demonstration of what biology can be done outside the lab. Thank you very much for showing us the path. It was outstanding. Thank you very much for my dear secretary colleague to join us here today. I think it's a real pleasure to have you here. In fact, we would love to come and hear about more about biological weapons and weapons which is now becoming a very important. But I think the biology is actually taking a completely new dimension in this world. And that is where you can see the impact of Department of Biotechnology is completely changing into how funding transforms ideas into impactful solutions. And as I said, Professor C.R. Babu, it was a delight to have you here. Life is much more outside the labs, that's what you've shown. And I hope our BRIC family and DBT family would remember these words of how to do things outside the lab and not just only sequester yourself in those environments of rooms and labs. I think every science can be transformed into its own pedestal. So thank you very much for giving us this. Also, I want to congratulate the awardees, the I Got Karma Yogi awardees. Fantastic. Some of you, I just asked one of you said 225 courses. I know you have to appear for a quiz as well, so it's not just going through courses, but also appearing and clearing the quizzes. I think absolutely fantastic. Learning throughout the life is probably the most critical component of human endeavors, of everything. And I continue to do this. Also, race awardees, young fellows, but the energy and the enthusiasm with which for the first time you showed, I think we're all very thankful for Dr. Anand for showing the benevolence. Actually, on the spot, he kind of decided to award 1 lakh rupees to each one of them from his own personal money. So I'm sure, he's betting a lot on you guys to deliver for the country. So thank you very much again and wonderful congratulations to do. Also, finally, the unified portal of Sahaj infrastructure, which Dr. Debashish talked about, please use it. I don't like to make things mandatory because, it really always pushes you down the throat, doesn't really help. But it's a fantastic stuff which really integrates the entire ecosystem and allows you to really ensure that the investment that government is putting into these instruments, high-end instrumentation, and the technical human resource that has developed in these institutions is used to the maximal benefit of the people. And that's been one of our DBT's hallmark of doing these activities. So let me try and talk to you about some of the things. Let me first thank you, each one of you from Department of Biotechnology and its bigger families for all the wonderful stuff that you have done over the last 3 years that I've been here and you've been doing for several years of time. I think it's amazing as a team what we all do in Department of Biotechnology. It's a very, very cohesive team. And there are people who come and work and help us out at any point of time. And I don't want to take names, but all of you know, some of you actually have been absolutely outstanding, and I cannot do whatever I'm talking to you about cannot happen without the endeavors of these people actually. So thank you again, all of you, and I think we should have a big round of applause for each one of you of what you have done, both past and present Department of Biotechnology people. I think in my past 3 years of learning, if I want to say what I have learned, the only thing more complex than biology now I've realized is the funding paperwork actually. And this running through DBT circles and all the ideas and thought processes that we bring in, I think it's really, really tough to really navigate these challenges. And some of these have been complicated by governmental interference into various activities, which I have listed it out as the year of new acronyms actually. And it's fun to see how many new acronyms have we come up with in last 1 year of time. And all of you can maybe recite along with me. So the first one is CNA. What is it? Central Nodal Agency. I think all of you should know this. TSA, Treasury Single Account. BioE3, Biotechnology for Economy, Environment. Just have energy in it. It will put you into the energies. Just talk about the acronyms. BioRide. How many of you can talk about this? Biotechnology Research, Innovation and Entrepreneurship and Development, which is a scheme of Department of Biotechnology. I3C, ideate, immerse, innovate, collaborate. So we continue to add acronyms into our kitties actually as we continue to go along. And BRIC, which is Biotechnology Research Innovation Council. You can see each one of these has been an event and a milestone in DBT's perspective from a variety of ways. And we have been innovative in our own minds and our own ideas and our ways in which we are trying to bring in this to the people, to the best of the people, in whatever ways it makes differences to the life. So I think let me really talk about what Department of Biotechnology has done over the years. And as Professor C.R. Babu also said, we are entering into 40th year of our wisdom. And according to Hindi mythology, the 40th year is a very, very critical, we always do the saying it by having the vision. Your vision gets improved because you need specs from there. But I think Department of Biotechnology is truly entering into an era which is quite unprecedented for what it has to deliver. And that means there are enormous opportunities and challenges and really trajectories which we have not dwelled upon as of earlier point of time. And you can see what DBT has done over the years is have tremendous innovation, cutting edge research, capacity building, entrepreneurship with Bairak's help. MD Bairak is here and the other team members are there. And now we are more and more focusing on the bioeconomy aspect of the country itself. What that means is we are transcending and cumulatively accumulating our focus and emphasis onto the perspective that what will drive Indian economy. And I think that's where we thought the ecological restoration be one of the critical component of bioeconomic development actually. We thought we should invite you, sir, for this wonderful lecture. So what have we done well and why Department of Biotechnology is such a powerhouse of one of the government departments actually. And let me tell you, this is my own study. I think what we have been able to do really well is to bridge linkages for innovation and growth for almost now more than a decade between government, academia and the companies actually. And this is very unique to Department of Biotechnology where we have Section 8 companies, we've got companies for profit companies, we have academic environment which is absolutely outstanding, which is now called Biotechnology Research Innovation Council. And of course our research innovation and policy and guidelines have been clearly way ahead of its time. For example, last couple of years, the gene editing guidelines that we released actually is obviously, were way ahead of even Europe had even thinking about it actually. And I think all credit to officers of being able to bring together along with various people from, community who have contributed to it. So this has been our real USP actually, I think. Why we are more and more critical and important actually. And this is my slide that gives you how revolutions, scientific and industrial revolutions in the world completely drives changes in the way they come and they change everything. And what we are going to envisage actually, if you really look at from the 17th century, middle of 17th century to the 21st century, what we're talking about now, you can see around the early part of the time, the industrial revolution mechanized the whole ecosystem. It kind of converted into a larger mechanisms of how one can carry out these activities. The next generation was electrified, for electrification of these activities where electricity and various other kind of new automobile mass production started to. The third one that we all have seen in our own lifetime is the digitalized world actually. And that's where now what we are right now. But the next 25 years are going to be amalgamation of all these four to really take to what I call biologize the world actually. And this biologizing the world requires completely different set of rules and regulations because it's the precision, the dimensionality and the time scales, what biology works is absolutely outstanding and completely unique of its own kind. And what Department of Biotechnology has to really work is towards this, what I call industrialization biology, or how to make biology into much more usable work, part of life. And you can see all the countries that have adapted to these technologies earlier have their GDPs increased so that the economic benefits continue to grow. And the countries that are not really, could not climb this ladder very early on are actually lying somewhere here. And India is somewhere in the middle income country right now, LMIC country, where we still have to aspire. And I think the opportunity for us is for the Viksit Bharat is really to make this steep climb, which is what all of us are talking about. And the only way it can happen is while embracing all these 4 sectors, we actually bring biology into it and really take leads to create ecosystem and society that is far more integrated and innovative in its own dimensions. So this is what I always think that DBT does actually. It's just not a funding agency, but it forges what I call collective intelligence and networking actually. It brings people together, it makes bridges, it connects ideas, it develops various programs and platforms. And I think that's what is the real strength of this Department of Biotechnology there. I think as we embark upon this journey of engineering Bharat's biovision, what we now see is a tantalizing glimpse of what might be possible actually. But really, these are what we are now looking at in next 25 years, which will almost become a reality. It is like personalized disease treatments, materials grown by microbes instead of extracted from petroleum, sensors capable of detecting everything from emerging pathogens, and the list can be go on and on actually. And how to be able to do this, in my opinion, there are only 3 things required right now. Integration of biology with technology and some really purpose-driven people actually who really want to transform this world and not just really be part of it. And that's where I think the real emphasis on Indian ecosystem building is there, is how to drive purpose-driven people in this organization such that you not only suffice to what you can do, but what you can deliver and what you can, reach out to the other parts of the world. How do we really do this? And I have just listed out how engineering of living organisms could soon start changing everything actually. And you would very soon realize that we're talking about engineering, and very early in our schools, we are asked whether you want to become an engineer or whether you want to go medical or a biology side actually. So we are diversifying our mindset at the 9th standard in our country. And now we are asking them to come together and bring together your prowess to make sure that we actually create this ecosystem. Now without engineers, believe me, the biology is almost going to be non-extinct now actually. I think the engineering principles and their ability to scale is what biology requires, and really that is where the real bottlenecks are. And you can see I've just listed it, and you don't have to read through it. All of you can add more to it actually from your own perspective. But there is enormous opportunities for each one of us to actually climb upon and take up responsibilities and make sure this happens. This is why what is shaping the sustainable future are 3 really brackets that I like to put together actually. The first one is health bio, which is obviously the key to human life. If your health is okay, your first part of your life is perfectly okay, then you can start delivering your work. The second one is the hyperscale biology. And that's why, as I said, one of the classical examples was given by actually the hyperscale biology is of ecological restoration actually, where you really expand it towards engineering principles and ecological balances, which actually transcends into earth bio and also climate change innovations, green chemistry, cultivations and solutions for future planetary scales. So these are problems that require completely different dimensions of what we presently do in our laboratories and our own zones of activities. And therefore, this demands that we really change our ways and look at principles that are very, very unique of its kind. I think some of the key successes for this year, and I want to re-highlight the Genome India program actually was a fabulous success of what bringing people together makes it into a large venture and enterprise. And you can see about 20 collaborating institutions from 15 states actually completed 10,000 genome sequencing from 83 populations now, which is the data is present at the IBDC portal. There's also a framework available for exchange of protocols, and Honorable Prime Minister actually in fact unveiled the genomic data, whereas the Minister launched this actually. So it's a very, very significant milestone for the country's progress, because what we are now saying is that we have a baseline data of what our population exists, what are the genomic variants of healthy population. And that's why we need to work on other kind of perspective of how other populations, disease populations, their variants and their rare variants would appear and emerge into diseases. just to supplement this, and this we are going to announce next month, we are completing about 10,000 genomes of Mycobacterium tuberculosis actually as a way to look at can we use AI and drug resistance predictions using the genomes of Mycobacterium tuberculosis led by Dr. Mohanty and from NII here actually. And this purpose is that we have set up a strain repository of all these organisms, about 10,000 of them will be present at ICGED. And these drug-resistant strains should in fact be available for doing all sorts of studies and activities. Presently, these genomes, about 6,000 of them have been completed, and the samples have been collected for 15,000 samples actually. So you can see the large activities of collective bringing people together from different areas and different institutions has tremendous power to change and deliver the dimensions of the scales that we are all wanting to look at and do actually. I think these are also a couple of some really good events that happened. India's first ferret facility got set up in BRIC PHSTI actually, and this is the first of its kind in the country for doing flu research and variety of other preclinical studies that can be done. Similarly, India's second non-human primate BSL-3 facility was set up at NII actually, so where you can do aerosol-based challenge to do BSL-3. I think NIV was the only other organization that had these facilities. So you can see while we are bringing together various programs, ideas and people and infrastructure, we're actually kind of embarking upon a variety of ways. In the case of agriculture sector also, DBT set up 3 fast breeding centers, one at Varanasi that was set up 2 years back, in Ludhiana was set up last year, and this year we set up one at the DBT institutions called Navi actually, BRIC Navi, where all these now provides an accelerated way to test out your varieties and other mutants that you develop in your lab, such that you can use these facilities by changing day and night cycle and changing the variety of parameters. You can in fact grow these plants at a faster rate to establish and develop wealth of data that can be then used to deploy. In fact, you can see one of the recently completed work in rice genome data analysis was completed, which would have taken 7 years in the field, could be completed in about 2 years' time in the Varanasi field breeding center. So you can see in variety of dimensions, DBT is playing an enormous role actually of various on one side clinical, preclinical studies, on other side developing agriculture resources in terms of setting up new programs for genomics related precision medicine activities. And together, this is really an enterprise that is going to drive the future of the country. I therefore think that the key to all of these are 3 main buckets that I always like to call people, process and product actually. And if you focus on all these 3 aspects, innovations and reforms can really drive country into a completely multidimensional growth that we are all looking for. And one of the ones that I'm really proud of is actually the I3C BRIC RCB PhD program, very well maintained, mentored by Arvind, who is here actually. And this is really a transformative PhD program because what we are going to do is trying to change 150 years of degree activities of PhD, how it was going on actually. It was all got to do with the individual problems and individual PIs and individual theses. What we are trying to do is to define and foster scientists that are more cross-disciplinary and working in team-oriented environments, which is the real critical need for solving these complex problems and issues actually. The second one is actually obviously in terms of efficiency, we set up a model which is emerging frontiers in biotechnology and fantastically carried forward by Sanjay Kalia and his team actually, where we fund any program in large areas of biological sciences is funded within 6 months of its submission, and release of grant happens within the 6 months of time. We've already released more than 150 such grantees, awardees, and I think this is fantastic because 6 months is a time when you really want to bootstrap and fast track the individual driven PI research programs actively. And in terms of product, we actually kind of did strategic merger from National Agri Biomanufacturing Institute by merging Nabi and SIAB, which used to exist on the same campus in Mohali, facing each other. Now they have become a part of one single activity. And I think it's again very significant because we now have named this institute as Agri-Food and Biomanufacturing Institute. Also, we have, as I think, going along the pathways, DBT has always had program managers that plan and execute constantly evolving portfolio of research programs and challenges. And one of this that we are going to embark upon is what we call Bio AI Pitch Days actually. This is an area where integration of biology and artificial intelligence needs to come together. And we are going to have a lot of pitching all around the country, where we will select and award Bio-AI catalyst projects that can actually transform the closed loop projects of biological perspective using the METI's already existing infrastructure that we have agreed with them as co-partner with the activities, so that we can provide solutions and projects for future of the country. Something similar, what we are going to do is actually to define the IBRIC institutions have identified a new model of governance which will have a transformative power to define bold global actions. We are kind of calling it IBRIC units of excellences, virtual units of excellences. The purpose of this is really to integrate areas of different and align technological innovation ecosystem. So these are going to be around the single virtual central hub, which will consist of various specialized pods, and these pods will have one area of expertise, unique set of faculties and semi-autonomous units actually. And this will then connect with collaborative nodes so that we can have partnering SPs and regional innovation systems connected into one single system. And this way we will have kind of a gigantic network of people, which is very critical and important for larger perspective for our innovation ecosystem to grow actually. I mean, for example, if we take an example of cancer biology, you will have an SP1, not as a cancer, SP1, GCH will be a cancer biology, whereas SP1 could be the genomics of all cancer biology. The SP2 could be the, looking at variant population and pharmacological perspective for it. Similarly, you will have these pods and various scientists can get connected with it. And the VCH will actually, provide immediate grants and funds to these SPs, which will then provide and connect through this collaborative network to create a partnership model for future perspective. Similarly, in terms of entrepreneurship innovation ecosystem, we are trying to set up this model, what we call entrepreneurship in residence. It's actually practiced in several countries abroad as well. It's a model where IBRIC scientists keen to commercialize ideas and connect with venture capitalists. And these VCs early on itself then tries to connect with the labs and gives 2 years of fellowship activities such that they develop the program in the lab to further to bring it to some value. And then this EIR would be an individual who was keen to explore and have an entrepreneurial career, and eventually can float a company after 2 years, where these venture capital can in fact be the first right to invest actually into these companies. So you tie up pieces of these people very early on, so that you actually, people who have developed the science in the lab can take it to the proof of principle in the lab itself along with the PI, and then being funded by a venture capitalist who will then provide the first right to investment into the company, and therefore I think can provide a rather nurturing deep tech entrepreneurship ecosystem. Finally, I come to this BioE3 policy, which has been one of the key parameter of what DBT is wanting to do and future goals of this. I think Union Cabinet, chaired by Honorable Prime Minister, approved this BioE3 policy on August 24th. It's called Biotechnology for Economy, Environment and Employment. And sir, you would be happy to note that we have put environment as an integral part of this BioE3 policy actually. So we would love to have much more ecological restorations of activities with partnership with your leadership. This was also launched by Dr. Jitendra Singh in August 31st. Now the purpose of this policy is really to provide a framework for direction and future for scientific, industrial and societal advancement actually. How can we provide futuristic leadership to this country if we want to be among the global leaders in the next industrial revolution? And it's really a commitment to foster an advanced future that is more sustainable, innovative and responsive to global challenges actually. What we have also done is very critical and important perspective of it is to create jobs and intensify entrepreneurial momentum, because that's the need of the countries are actually, and how we can create more and more jobs by creating ecosystem that really helps us to ensure that these kind of activities will happen. So the strategic roadmap is really of biomanufacturing, where 6 different sectors have been identified, and I've talked several times, but just to recapitulate, the bio-based chemicals and enzymes, actually again a very, very large portfolio of bio-based enzymes, which is very, very critical and important to be able to scale up things and activities, functional foods and smart proteins. The food will not only come from agriculture, but will be supplemented through industrial methods and ways in variety of activities. Precision biotherapeutics, I've already shown you how genomics will play an important role for it. The climate resilient agriculture, how to really create a climate resilient agriculture where the earth is happy and helps you out to do these activities. The carbon capture and utilization, as you rightly showed, that the carbon capture of ecological survey and obviously oceans provides a tremendous opportunity to capture the carbon in a variety of ways. And the marine and space research obviously is the next frontier, where all the new areas of frontiers will define and work with it actually. The whole idea is to set up biomanufacturing and biofoundries all across the country. And we would like to have about close to 100 to 150 projects of biomanufacturing set up in next 2 years. That's the plan to do all across the country. These are at a hyperscale level, not at the level of just the laboratory level, but these are at the scales where you are kind of pre-commercial scales of programs, actually activities, so that they will develop into a completely new futuristic instrument. The bio-AI hubs I already talked about. We're probably going to come up with a different model of how pitches can be done and how challenge rounds can be provided, such that people come up with their own ideas and opportunities in few areas of sectors that we'll discuss it later. I think how do you build the bioeconomy of the country actually, and that's also DBT's enormous mandate to be able to catalyze these activities all across the country's zone actually. So what we're trying to do is we're trying to work with states actually, such that we leverage their collective strengths and advance S&T for the benefit of all. Now this is a regionally tailored approach, and Alka just was there at Advantage Assam yesterday, where Assam has kind of agreed to set up the Bio-E3 cell, which will decide and dictate how these activities will be driven through every state in a regionalistic manner, such that it kind of provides a regional touch to these activities. And you can see, again, in all these Bio-E3 cells, the people, process and product is going to be the focus. How do you develop skilled workforce through interconnecting people in a variety of ways, using already existing our incubators that are present in various states and other activities. Use processes to create bioreactors and all activities, and the products in variety of activities can be created. I think our endeavor is to create a network of Bio-E3 cells, which are interconnected knowledge hub linking states and national stakeholders. And these are not functional, these are only functional people. We are not going to create an infrastructure there really. It will be sitting inside our own bioincubators that are BioRacks bioincubators or biohubs of these places. And these nationwide network will ensure that the emerging technologies and innovation research provide sustainable biomanufacturing processes to integrate it across the region actually. And I think this is very critical and important, because till the states embark upon the bioeconomic zones of activities, we will never be able to scale, because there are variety of activities that requires approval processes and variety of other involvement of these. So obviously their job would be to do policy coordination, knowledge exchange, technology adoption, and align to local priorities. And these Bio-E3 cells, as I said, belongs to the state activity funded by Department of Biotechnology. I think one of the key aspects what we have done in I3C, which is really very happy about, is all the students before going to the lab has been asked to work in the fields. And you can see this is an example where they go out and reach out to the people, such that you do problem solving approach very early, learn very early in your time. And we were not unsure about, not sure how students would take it up at such an early young age. But it's fascinating that they're really enjoying their time. They have been provided funding by Grant Challenges India through BioRacks mechanism actually. And they have been supplemented with a fellowship to work in the fields and be able to ensure that you bring in exciting opportunities and knowledge that is very useful, as well as the confidence to back into the labs to make sure this happens. There are 13 immersion partners all across the country who are helping us out in this program, and there are about 58 students who are in the field right now doing a variety of activities. I think I'll finally leave you with the words of Honorable Prime Minister, who spoke actually at the genomic conclave that he talked about, because he really very beautifully summarizes what biotechnology is all about right now. And I'll stop here.
साथियों, 21वीं सदी में बायोटेक्नोलॉजी और बायोमास का कॉम्बिनेशन बायो इकोनॉमी के रूप में विकसित भारत की बुनियाद का अहम हिस्सा है। बायो इकोनॉमी का लक्ष्य होता है नेचुरल रिसोर्सेज का सही इस्तेमाल, बायो बेस्ड प्रोडक्ट्स और सर्विसेज का प्रमोशन और इस सेक्टर में रोजगार के नए मौके बनाना। बायो इकोनॉमी सस्टेनेबल डेवलपमेंट को गति देती है, इनोवेशन को अवसर देती है। मुझे खुशी है कि बीते 10 वर्षों में देश की बायो इकोनॉमी तेजी से आगे बढ़ी है। साल 2014 में जो बायो इकोनॉमी $10 बिलियन की थी, वो आज $150 बिलियन से ज्यादा की हो गई। भारत अपनी बायो इकोनॉमी को नई बुलंदी देने में भी जुटा है। कुछ समय पहले ही भारत ने बायो E3 पॉलिसी की शुरुआत की। इस पॉलिसी का विजन ये है कि भारत आईटी रिवॉल्यूशन की तरफ ग्लोबल बायोटेक लैंडस्केप में भी एक लीडर बनकर उभरे। इसमें आप सभी वैज्ञानिकों की बड़ी भूमिका है और इसके लिए मैं आपको अपनी शुभकामनाएं देता हूं।
I think we'll stop here, but Department of Biotechnology, as I say, has a new acronym as well called Delivering Better Tomorrow, Delivering a Better Tomorrow. And I think I thank you, each one of you, really for all the endeavors that you are doing, all the BRIC directors, all the past and present people, and BIRAC for really supporting this endeavor actually. And I think together, this team is absolutely stunning. Thank you very much.
Thank you, sir, for your encouraging words for the entire DBT family and underscoring the importance of people, process, and product for enhancing synergy and collaborations, for spearheading innovative initiatives to strengthen biotech sector. So, as is customary for celebrating birthdays, we have a small cake cutting ceremony. And as the head of DBT family, may I request Secretary DBT to kindly take the lead. And I also request all the dignitaries on dais to join in. May I also request MD Bairek to kindly join the dignitaries on dais. I also request all the IBRIC directors who are here in the audience to kindly join the dignitaries on dais. Sir, please. May I also request Ms. Ekta Bishnoi, Joint Secretary DBT, to kindly join the dignitaries on dais. It's both an honor and privilege to stand before you to express my deepest gratitude on behalf of Department of Biotechnology as we conclude the celebratory event for the 39th Foundation Day of the department. At the onset, I would like to extend my sincere thanks to Secretary DBT, Dr. Rajesh S. Gokhale, for his invaluable mentorship, unwavering support, and thought-provoking perspectives. Thank you, sir, for the personal example you set for all of us and instilling in us the confidence to work together as a team for achieving the goals set forth. We are immensely thankful to Dr. Sameet Kamath, Secretary, Department of Defense R&D, and Chairman DRDO, for sparing his valuable time and joining us today in celebrating the Foundation Day with us. Thank you, sir. I extend a heartfelt thanks to Professor C.R. Babu for delivering an awe-inspiring lecture. It's bound to make all of us ponder over ways by which we can minimize our planetary footprint and contribute in safeguarding environment through every small step we take. I also place on record deep appreciation and thanks for Dr. Alka Sharma, Senior Advisor DBT, and Dr. Sanjay Mishra, Senior Advisor DBT, for their passion and unflinching support in all departmental activities. I'm extremely thankful to MD Bairak for sparing his valuable time and for his steadfast efforts in connecting department activities with the bioindustry ecosystem. I also thank Ms. Ekta Bishnoi, Joint Secretary DBT, for her unstinted support in all departmental activities. We are immensely thankful to Director NII for Dr. Debashish Mohanty for hosting today's ceremony. And we are also thankful to his entire team for providing all the logistic support. We are also thankful to the former senior advisors of the department, all the directors of DBT Autonomous Institutes for accepting the department's invitation and joining us today. I also once again like to thank Dr. Anand S. Deshpande, founder and chairman, Persistent Systems, for his support in brick-related activities and for his generous contributions in encouraging the students from across iBrick Plus for their entrepreneurial journey. I also thank all the race winners as well as the top performers of the IGOT for their participation in the departmental activities and making the most use of it. Further, I also thank all the members of the audience for their presence. Thank you all for participating in this event. May I request everyone to kindly join for high tea arranged outside the auditorium.